हाँ बोलो। हाँ 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 हाँ। মানে আরো 3 মাস পরে কাটছে।
হয়।
হ্যাঁ হ্যাঁ হুম, আচ্ছা কত বললো তাহলে তো? আচ্ছা ডাক্তার দেখাচ্ছিল, দেখানোর পর ডাক্তার দেখাচ্ছিল।
Hello, Shivshankar, I'm audible. Please just confirm.
Good evening, sir.
Yeah, good evening, very good evening. So, hope the slide is visible. First slide.
Okay, sir. Yes, sir. Visible, sir.
Okay, okay, fine. Let us wait 2 3 minutes. Maybe another participant will join. Then we'll
Okay,
start the
sir.
session.
Yes, sir.
Okay, let us wait 2 3 minutes. Then I'll start.
Yes.
Okay, let us start. So, hopefully, in between the session, the participant will join. So, now I have started the recording. So, let us start with the questions. So, the today the third week, so we are going to discuss question about your conservation of mass and conservation of momentum and Renault transport theorem. So the major focus of this question answer session will be based on these two. Okay, so I have the previous year also questions, the previous year NPTEL live session. So here the answer is also given. So you please go through one by one, or you can explore. So now let us start with the new questions. So the new question is, let me just go through. Yes, the new question is starting from here. So the first question is, in fluid flow, the line of constant piezometric head. The question is talking about here the constant piezometric head passes through 2 points which have the same elevation, pressure, velocity or velocity potential. So the four option is there. So please just try to think and write your answer in the chat box. Yes, please. So the main focus for this question is constant piezometric head at 2 points. Let us suppose in a pipe, point is there, and at both point the constant piezometric head is available. So in that situation, the what will be the same, whether elevation, pressure, velocity and velocity potential. The question is this. So please just try to write your answer in the chat box. Let me just write here, this is A, B, C, D. Which option will be correct?
Velocity potential, sir.
Okay, you are telling the velocity potential. Okay. So actually you have here two options, velocity potential and velocity. So which option will be correct? Okay, you are telling the velocity potential. So first try to understand what is piezometric head. So you know already the Bernoulli equation, P by rho z plus V square by 2z plus datum head, Z I am writing here, which is equal to constant. This is your equation, Bernoulli equation. So piezometric head is combination of these two, your pressure head plus datum head. So P by rho z plus Z is constant at 2 points. Let us suppose you have 2 points. One is here and another is here. So let us suppose the value of this C1, here is C1, 1 and 2. Here also C1 at both places. That is C1 and C1. At both places your piezometric head is this. So now your equation here, as you can see, the constant. So for maintaining the constant, this term should be constant at both places, and this term is depend on what? Velocity. This term should be constant at both places, so this term is depend on velocity. So the explanation is given here, as you can see the explanation. So this is velocity head, pressure head and datum head. The sum of datum head and the pressure head is called the piezometric head, and sum of piezometric head and velocity is constant during the flow, as Bernoulli equation is still. So for the constant piezometric head between 2 points, the velocity will remain same, because your the first you just think on that. In the objective type question, you need to select the best appropriate answer. So if the velocity was not there, then you can go through the velocity potential. If the velocity is there, you will go through velocity. So here option C will be correct. Now let us move on the next question. Yes. So half P by half rho V square is called the constant pressure, low pressure, high pressure or dynamic pressure. So please think on that, and you can write answer in the chat box, or you can unmute and directly can tell your answer. So this topic is very important for your competitive exam point of view also, or NPTEL final exam also. So this is very important.
Option D, dynamic pressure.
Yes, you are telling the dynamic pressure. Yes, you are correct. So dynamic pressure this is. So this term is also known as your the velocity potential because V square by 2Z, because this term is coming from here. The velocity potential is known as V square by 2Z. So yes, you can say this is the dynamic pressure, because here as you can see the V square by 2Z, there is no pressure term and datum term. Okay, so Ravi, the slide is visible? Please just confirm.
Yes, sir, it's visible.
Okay, thank you. So we have already solved one question. The question was about the piezometric head, and the correct answer was velocity. So after uploading the video, you can go through, right? Now let us move on the next question. The second question was about this. The half rho V square is called the dynamic pressure. Now let us move on the next question. So here you can see the very explanation. I have explained very well. So static pressure. So explanation is given. You please go through. I'll upload the PDF. So let us move on the next question. Which one of the following law of conservation forms the basis of continuity equation? This is your question number 3. Conservation of energy, conservation of mass, momentum, and the conservation of moment of inertia. So which option will be correct? Question number 3. Okay, Ravi is telling B, conservation of mass. Other, please also just try to write your answer, or you can unmute. So Ravi is telling option B, yes, the conservation of mass. So in simple way, what is conservation of mass? Let me just explain you. Let us suppose a flow through pipe, or you can consider flow through open channel also, no problem. So let us suppose here mass in is 10, 10 unit, and the mass out should also be, this is in and this is out. Mass should out also be your 10. So this is basically the conservation of mass. But in the mathematical way, in the simple way, we represent this. If here the area is A1 and velocity is V1, and similarly this is section 1 and section 2. So here area is A2 and velocity is V2. So the conservation of mass, because this should be in and out should be equal. I am telling these things, in and out should be equal. So A1 V1 is equal to A2 V2. So this is a simple way of understanding of mass of conservation. So this is and the answer for the question number 3 is B. So now let us move in the next question. So explanation is given here, as you can go through after uploading the PDF. Let us move with the next. This is question number 4. So here we are talking about the Bernoulli's theorem deals with the conservation of mass, force, momentum or energy. Which option will be correct? B, and here is C, and here is D. So Bernoulli's theorem deals with the conservation of which? So Nitish is telling option D. Okay. Other student Ravi is also telling D. Okay. So you are telling the Bernoulli's theorem deals with the conservation of energy. Yes. So you both are correct. And here explanation is given. So I will not explain. Now one numerical is there. Question number 5. A fluid jet discharging from a 4 centimeter diameter orifice has 4 centimeter diameter orifice has a diameter 3 centimeter at its vena contracta. If the coefficient of velocity is 0.98, the coefficient of discharge for the orifice will be. So here you need to find out the coefficient of discharge. So this is option A, option B, C and D. So just please think on that and try to calculate. So for this you have 3 minutes. Within 3 minutes please just try to write your answer in the chat box. First try to calculate using your calculator and pen copy. Then just write in the chat box. So I am repeating the question again because mic was not in proper alignment. So the question 5 is a fluid jet discharging from a 4 centimeter diameter orifice has a diameter 3 centimeter at its vena contracta. If the coefficient of velocity is 0.98, the coefficient of discharge for the orifice will be how much? So the option is there. So please just try to calculate. And let me just explain the previous question because mic was not. So Bernoulli's theorem deals with the conservation of energy. So now you people just solve question number 5. very simple question, just try to think and try to calculate. So talking about here discharge, so discharge, as you know, the area and velocity. So area times velocity, so definitely the coefficient also will be like that. Area, the coefficient of vena contracta, the combination of vena contracta and diameter, then the coefficient of discharge. So like that you can just try to calculate. This is just hint. So I'll give 2 minutes more, after that I'll explain.
पहुंच गया डॉक्टर
रिकॉर्डिंग चल रहा है।
ठीक है मैं जा रहा हूँ सर बाहर है हाँ। बैग नीचे मैं खोल के जा रहा हूँ बोल देना ये गया खाने चाय पीने का आया तो ठीक है 2 घंटे से बैठा है बाहर ही है।
So let us discuss. Let me just open the unmute. Okay. So let us discuss. So we are talking about here the coefficient of discharge. So let me just think. Let me just write the equation. So as you know, the discharge is equal to your area into velocity. So coefficient should be like that also. So what is coefficient actually? The coefficient is, always remember, the discharge coefficient, velocity coefficient or area coefficient should be less than 1, or mostly less than 1. This is not mandatory rule less than 1, but mostly less than 1. So the maximum value can be 1. So let us suppose for any coefficient, so the actual things and theoretical things, actual and theoretical. So the coefficient of discharge is what? This is actual divided by coefficient of theoretical. Why I am telling the less than 1? Because you know already the theoretical will be always maximum than actual, because in the actual condition, so due to some error or some other things, so your actual value cannot equal to, sometimes equal, but in generally not equal to your theoretical. So that's why theoretical value is greater than actual. So hopefully you understand. So let us move with the next one, area. So similar like that, for area also, A actual and divided by A your theoretical. Similarly for velocity, your velocity actual divided by velocity theoretical. So in this question actually here is not about, we are talking about the actual area and theoretical area. So here is, you have the two diameter, first one is your 4 and second one is your 3. So here you need to understand what is your area coefficient. So the area coefficient is nothing but, here definition I have already given, this one, the actual discharge, this one, the ratio of area of jet at vena contracta to the area of orifice is known as coefficient of contraction. So here you know already, because coefficient of contraction is related to your area, that's why I was linking previously. So here you can write your the coefficient of, now I am writing in this equation, like this equation. So this is your C, the coefficient of contraction into coefficient of velocity. So in your question you need to calculate coefficient of discharge, and coefficient of velocity is already given. So velocity is 0.98, and what is coefficient of contraction? So the ratio of area of jet, so this is jet divided by at vena contracta, the ratio of jet at vena contracta, ratio of jet at vena, I am writing like that, to the area of orifice, area of orifice. So now let me just go through your question. So here is given a fluid of jet discharging from a 4 centimeter diameter. So here the jet diameter is 4. So how you will calculate area? Pi by 4 into d square. So this is constant. So definitely your area is directly proportional to d square. So we can write here at the place of area, because here pi by 4 and in denominator also pi by 4, and here is d square, here is also d square, because both is area. So this will be, both will be cancel out, that's why here is written d1 by d2. So what is d1? So we are writing here d1 is nothing but your, this one has the a diameter 3 centimeter at its vena contracta. So at the place of d1, for the simplicity or understanding, for area jet at vena is, the diameter at this place is 3 centimeter and here is 4 centimeter. So the ratio will be 3 square divided by 4 square. So that's why here is written, and after the calculation you will get this one. The correct answer is this 0.98, 0.75, 10 raised to 2. And as you can simply understand, the 3 by 4 is nothing but 0.75, and square is there already, so that's fine. So now let us hope all you understand. So if yes, please you can write in the chat box yes, otherwise I'll explain again. So remember this formula is very important. So for just your understanding, you always think like that, the area is equal to, the discharge is equal to area into velocity, and from this you can understand the coefficient of discharge, coefficient of vena contracta, as well as coefficient of velocity. Okay, so now let us move with the next question. So next question, I think question number 6. When the water drawn from a central hole made in wash basin, hand basin actually, the type of flow of water is force vortex, free vortex, tangential flow, or this is the tangential flow or transitional flow. So here the 4 type of flow behavior is written. So just please try to write your answer in the chat box for question number 6. Which option will be correct? A, B, C and D. For question number 6. Nitish, you are telling for this question number 6, option B. Okay, then okay, fine. Let us wait. Other participant, please also you can write your answer in the chat box. Which option will be correct?
Option B.
Okay, you are also telling option B. Okay, let us check. Yes, definitely, because what is free vertex? Always remember, please, the vertex without any external force, and the force, as the name suggests, the vertex due to the external force. So definitely it will be the free vertex, and definition here is given. What is force vertex and what is free vertex? So let us read first the free vertex. Free vertex flow is defined as the vertex flow in which no external torque. Remember please, this is very very important. Here is no external and here some external. Remember please, some external torque is required. So this is the simple difference and the everything will remain. Example, as you can see, for the free vertex, the flow of liquid through a hole provided at the bottom of container like wash basin, as you can visualize in your home also. The flow of liquid around a circular bend in pipe, a whirlpool in a river. Option 4, the flow of fluid in a centrifugal pump casing. And what are the example for your force vertex? The first example, a vertical cylinder containing a liquid which is rotated about its central axis with a constant angular velocity. Next one, the flow of liquid inside the impeller of centrifugal pump. And third one, the flow of water through the runner of turbine. So hope you all got it. So now let us move with the next question. The next question from also your Bernoulli's principle. So according to Bernoulli principle, this is when a fluid's pressure decrease. Here we are talking about the fluid pressure decrease. What happened to the speed of fluid? So pressure and speed relation we are talking about here. So option A, it increase. B, it decreased. It remained constant. None of the above. So which option will be correct? This is a bit formula based question. So just you can think about the formula of Bernoulli's principle, and from the formula you can interpret it whether it will increase or decrease. Very important question. So please just try to think on that. So please just, okay, you are, Ravi is telling option A is correct. It increase, okay. Other student, please also just try to write your answer. So let me just give you hint little bit. So Bernoulli's principle, let me just write the equation, basic equation, plus v square by 2z plus z. So here, when a fluid pressure decrease, what happened to the speed of the fluid? So we are talking about this statement at a particular point. So if at a particular point, if pressure is increased, what happened with your velocity? So at a particular point, in both cases, let us suppose the previous case was something. In the second case, what happens? You have decreases or increases the, you have decreases the pressure. So in both cases, your Z will be constant. Remember please, in both cases, Z will be constant. So what remaining? P by rho z plus v square by 2z. This is variable, and this constant, I am taking this constant that side. So after the minus the constant, another constant value, so again it will become another constant. So here, as you can see very clearly, so for constant value, if you are increasing some, here you have the two term, this is the first term, this is the second term. If you are increasing something, then this term will be decrease, then you will get these things. If you are increasing this one, and if you are increasing this one, so you cannot get this, definitely this value will be increased. Let us suppose you have the 5 plus 6, 5 plus 4 is 10. So if you are increasing this one, 6, 5 plus 4 is 9, not 10. So if you are increasing this, so you have to increase this one, then you will get 9 again. So similar thing is here. If the pressure is increasing, when the fluid pressure is decreasing, so you are here decreasing something, the pressure is decreasing, so you have to, that is from 5 to you have decreasing up to 4, then you have to increase this one, then you will get this constant value. Why constant value you are getting here? Because at particular point your Z will be constant and C also will be constant. So for getting the similar constant value, you need to understand these things. So definitely your velocity will be increased. So this was the concept behind. So the explanation is given, as you can go through. Okay. Now another very important question. The piezometric head is the sum of pressure head, datum head, velocity head. Option A. Option B, datum head and velocity head. Option C, pressure head and velocity head. Option D, pressure head and datum head. So which option will be correct for question number 8? Very important question. So please just try to write your answer in the chat box. So as we are discussing Bernoulli's equation, so this is also from your same equation. So Nitish is telling D option. Okay, as I have discussed earlier also about the piezometric head, Ravi also telling D, the pressure head and the datum head. Yes, already I have told in the previous questions also. P by rho z plus v square by 2z plus z. So these two term is known as piezometric head. Remember please. Now let us move with the next question. So here is explained very well. The piezometric head is your combination of these two. And what is your P by rho z? The pressure energy per unit weight. You can tell this also, the pressure energy per unit weight or pressure head you can say. What is V square by 2G? Kinetic energy per unit weight or kinetic energy head. The potential energy per unit weight or elevation head you can say. So always remember. So never confuse from your potential energy and piezometry. These look like similar, the similar sounds, but never forget these two things, the potential energy and piezometric head. Now let us move with the next question. Very important question. So question number, I think, whatever question. So which of the following equation are used for the derivation of differential equation? Here we are talking about the derivation of differential equation for water surface profile in open channel flow. So continuity equation, energy equation, momentum equation. So which option will be correct? So here actually don't think about it, the open channel, because open channel not covered, but just try to think you want to calculate the differential equation for water surface profile in an open channel or river system you can say. So what will be the correct combination, whether energy continuity or energy, whether continuity momentum or only continuity, only energy, only momentum. So here option is given. Option A, only A. Option B, only B. Only C, and D, both A and B. So please you can think on that. Okay. So Ravi is telling B option and Nitish is telling A. Okay. Other student, please also you can write your answer in the chat box.
Option D.
You are telling both, okay? Means you need continuity and energy, okay? Yes, definitely. For calculating your water surface profile or differential equation water surface profile for water surface profile in open channel, you need continuity equation, definitely continuity equation, mass in and mass out, along with you need energy equation. So how it look like? So you can see here, water flowing in a channel with a free surface is usually referred as open channel flow. Means water is flowing in the channel with free surface, means atmospheric pressure is acting here, atmospheric pressure. But in the pipe flow, or you can say the pressurized flow, there is no atmospheric pressure acting within the your fluid, on the fluid. Here atmospheric pressure is acting on the fluid. Here atmospheric pressure acting on your pipe, not on the fluid. So this type of flow is known as open channel flow, and this is pressurized flow. Pipe flow can also be your open channel when it flow half or little bit above some space between the your fluid surface, whatever the flowing, and your the wall of the pipe. So this is not mandatory rule for open channel flow. Always the top will be open. There is no rule. You can in pipe also the your open flow possible. The main criteria is on the fluid surface your atmospheric pressure should be 8. Okay, so now come again on the question. The open channel flow equations are divided from the fundamental three-dimensional equations of fluid mechanics. One is continuity. So the continuity equation here, as we have already seen, A1 V1 is equal to A2 A2. So this is very simple one, mass in and mass out. But for the calculating your differential equation or differential equation for your free surface flow, so you need to sum the differential form of your continuity equation. So this is your differential form of continuity equation, and similarly your energy equation is written here. So as you can follow, and you can go through more. So now let us move with the next question. So here explanation is given continuity and as well as your energy equation which relate the Bernoulli's equation, and this one is related by this one. Why here rho 1 is written? One thing is very important, as you can see, this is rho 1. As I have previously told, this is a simple one, A2 A2. So this equation with the assumptions. What assumption? The density of the fluid will be remain at both point, that is here one first point and second point. So if the density is remain, that type of flow is known as with what name? Let me just give you steady flow. Second one is uniform, compressible, incompressible. So which option will be correct if the density at both places will be remain? Please everyone just try to write your answer. Everyone please. First one is your steady flow, second one is uniform flow, compressible, and fourth one is your incompressible. So such type of flow where your density is varying, that is known as compressible, and where is not varying, so incompressible. So this equation is valid for your incompressible and this is valid for your compressible. So such type of assumption remember always. So again very important question. Which of the following is and are correct? Here maybe the two option will be correct. Maybe one or two or three option correct, or all option may be correct. So please think like that. So option A, B, C and D. Maybe all option correct, maybe two option correct, maybe three option correct, maybe only one option is correct. So like that. Okay, Nitish is telling for previous question 4. Okay, good. So now the first option, to increase the discharge under a given head pipe must be installed in parallel to pipe. When pipe are installed in series, then discharge will be more for larger diameter pipe. In a real fluid flow, hydraulic gradient line can rise or fall, but the total energy line will always fall. Option D, the point above the hydraulic gradient line in the fluid pipe network always have positive pressure. So you have the four statement. So very important questions. So please just try to think on that, and you can write your answer in the chat box. So after this question, we'll take 5 minute break, but let us solve first this question. So you have 2-3 minutes, just think on that, read each option very carefully. After reading, you just try to write your answer. Maybe the 1, 2, 3 and all option may be correct. So this is multiple choice question. So Ravi is telling option 1 and 3 are correct. Okay. Nitish is telling A is right but B is wrong, but need more clear information about option C and D. Okay.
Option A, sir.
Okay, you are telling option A, to increase the discharge under a given head must be installed in parallel. Okay. In a real fluid flow, hydraulic gradient line can rise or fall. Okay. So just I want to show you the answer. As you can see here, to increase the discharge under a given head pipe must be installed in parallel. Why? I'll just explain you. Next one, in a real fluid flow, in a real fluid flow, hydraulic gradient line can rise or fall, but the total energy line will always fall. Why fall? You know already, due to the friction and all. So we'll discuss. So now as you can see here, and this is why this is wrong, this your, when the pipe are installed in a series, then the discharge will be more for large diameter pipe. No, nothing like that. As per the mass conservation, as I was telling previously, Q1 is equal to Q2 for the continuity equation. So if the diameter is this much, and for the next is like that, and for next pipe is like that, so here is Q1, here is Q2, and here is Q3. All will be the same, because here area is increasing, velocity is decreasing. Here area is decreasing, velocity is increasing, and your discharge is the combination of both. This depend on two things, not only one things. So one is increasing, another is decreasing, so it will be combinedly at all locations in the series pipe discharge will be same. So this is wrong. And why this fourth one is wrong? The point above the hydraulic gradient line. First, what is hydraulic gradient line? Let me just explain. I'll explain a little bit later. In the fluid pipe, the network, in the fluid pipe network, always the positive pressure. So let me just go one by one first. Pipe in series. First we are talking about pipe in series. So pipe in series or a compound pipes are defined as the pipe of different length and different diameter connected end to end. End to end means this is 1, then 2, then 3. From a pipeline, the discharge through each pipe will be the same. Total loss of energy or head loss will be the sum of loss in each pipe. So total loss will be this one. Remember please. Total loss in head is equal to the loss in this, because what? Each pipe have the loss. Just think on that. Each pipe have loss, because the internal friction, here is the contraction, here is the contraction, here is the expansion. So due to this also loss will be there. So two things remain. In the series pipe, discharge will be the same, but head will be the, that is the total head loss. Total I'll write here. So HL1 plus HL2 or HL3 you can say, if the 3 pipe is there. If 2 pipes, so HL1 and HL2. Now let us move with the pipe in parallel. So if the main pipe divide into, here you can see the figure, if the main pipe divide into 2 or more branches, this main pipe is divided in 3 parts, 1, 2 and 3, again joined together downstream to form a single pipe. Here you can see the single pipe formation. From the 1 dividing 3, then single, again single. Then the branch pipe are said to be connected in parallel or compound pipe. This is parallel, you can see here. This is parallel, these all 3. The rate of flow in the main pipe is equal to the sum of rate flow to the branch pipe. Definitely, if let us suppose here 10 is coming, so if here is going 6, then definitely here will be the, maybe if here this side is going 3, so this side will be going 1. So it may be the another ratio also, 6 to 2 you can write like that. It's depend on the diameter and the orientation of your pipe. Therefore, pipe are connected in series Therefore, the pipe are connected in series to increase the pressure at the same discharge. The pipe are connected in parallel to each other to increase the discharge at the same pressure. So this is important. Remember. What is written? Let me just read again. The pipe are connected in series to increase the pressure. The pipe are connected in the series to increase the pressure at the same discharge. And let us suppose if you have the discharge same, then for increasing the pressure you need to connect the pipe in series. The meaning of this, a pipe are connected in parallel to each other to increase the discharge at the same pressure. If you have the pressure same and you want to increase the discharge, then you need to connect this one. So this was the, I think, yes, to increase the discharge under a given head pipe means pressure. Here we are talking about pressure. The pipe must be installed in parallel. For when we install the series, if you have the same discharge and you need to more pressure, then you need to connect the in series. Next, what is hydraulic gradient line and total gradient line? So very important. Hydraulic gradient line HGL is the line formed by joining the piezometric head at the various location of fluid flow. Let us suppose you have one pipe, water is flowing like that, and you have the lot of points here, point 1, point 2, point 3 and point 4. So here you have the some pressure P1 by rho z plus data mat. P1 by rho z, this is P2 by rho z plus Z2. Similarly for this, and for P4, P4 by 0.4 rho z plus Z4, this is 3. And let us suppose this value is coming your 10, this value is coming around 9, this is 8 and this is 7. So you will just plot here. So if you are taking, if this is 10, if the level of 10 is this, definitely your level of 9 will be little bit lower, level of 8 will be little bit lower, level of 7 will be little bit lower. So your line will be connected like that. This is your hydraulic gradient line. Only we are considering these two terms, piezometric head. Now, what is total gradient line? Total gradient line is the line formed by joining the location of total energy at various locations. Total energy means P1 by rho z, Z1 plus V square by 2z, then V square by 2z, here also V square by 2z plus V square by 2z, and this is 4, this is V3 and this is V2 and this is V1. So after calculating, let us suppose you get the 15, then 14, then you here got 13 and then 12. So similarly, if this was the 10, after that 15 you will get here. So total energy line will be like that. And why it is falling? Because due to the friction of the pipe, your head is decreasing, head loss is decreasing, as you know the formula of the Wisbach formula. So here is the, just think on that. So what is up to that, your height is what? P1 by rho z plus Z, and this one is V square by 2z. So here it is written the difference of TEL, this is TEL, and HGL is always equal to the kinetic head. Remember these things, because when you will minus these two things, you will get this one, V square by 2z. The point above the HGL in the fluid flow network have negative pressure. the point on HGL which coincide with the pipe network have zero pressure. The point, this is very important, this term. The point below the HGL in the pipe network have the positive pressure. So always remember, the point above the HGL in a fluid pipe network have the negative pressure, and coincide is zero pressure, and below is positive pressure, remember. So total energy line will always be, here you can see, total energy line will always fall unless energy is provided from outside. Why? Because of the air friction, as I was telling. If we take the example of pump, then in that case there will be a jump in TEL. In that case, if you are taking the example of pump, because here you are giving some external energy, then your total energy line will not like that. Total energy something like that, as the pump will come from the pump location, your energy will be increasing. So like that. So now let us move with the next question. The discharge through a, okay, I'll take 5 minute break. So if you just read the question and try to solve the question and think the question. Here I'll take 5 minute break, please. So let us start again. So question is here, the discharge through the flat circular plate having a circular shape is hole orifice meter is. So we are actually here you need to write the formula, where in this formula CD is the coefficient of discharge, A1 and A0 are the area of the cross section upstream of the orifice and at orifice respectively. H is the differential head and G is the acceleration due to gravity. So which option will be correct? Whether A, B, C and D. So please just try to think on that. So if you are not able to remember the formula, what you will do, you can go through the dimension method. Here the question is asking about discharge. So if you know the unit of discharge, then you just try to find out discharge for this, discharge unit for this, discharge unit for this, and the unit for this, the whole term unit, whole term unit, whole term unit, in which term you are getting this, the discharge, the unit equal to the discharge, then unit same as the discharge not equal to, so you can definitely able to give the answer. So please think on that. This is the another way of solving such type of questions. But sometimes what happen, maybe the 2 and 3 options have the same unit, so in that situation you need to think in another way. But here just please first try to understand or try to calculate, then I'll talk, then I'll tell about this another trick also. So please everyone just try to write your answer in the chat box. You have 2-3 minutes, because this, if not know the unit, these your discharge unit, then you just try to find out the unit of discharge, then after you just try to calculate the unit of all terms, all options, then easily you can write your answer in the chat box. So everyone please just try.
Option B, sir.
Okay, you are telling option B. Okay, option B you are telling. Yes, definitely option B will be correct. How? Let me just, the discharge, the unit for the discharge is meter cube per second. So here you can see very easily. So area and area, means if this is meter square, for this also meter square, and one term is here meter square. So this meter square, once you will take outside of this root, 1 meter will be remains. So this is meter square means a square means what? The unit will be meter square square, that is meter 4. So this is meter 4. Once you will take outside for the root, meter square will be remain. So this meter square will be cancel out. So only meter square will be remain in this term. So here a like that. Here also meter square. Here is nothing, because here meter square. Here also meter square. This is nothing. Here also nothing. And what is 2gh? So 2gh. So this is your meter square per second. Meter per second square, not meter per second square root. And this h is your meter power 2 by 3 by 2 for first. For first is like that. For second, meter by second square, meter per second square into meter half, or you can say meter root also. So from here m half divided by second square into m half means meter per second. So this is meter per second, and another you have meter square and meter per second. So meter cube per second. So you can say from here the option B will be correct. So the always remember formula wise, your velocity is root 2gh. This is your velocity here, and this is your area term. This is your area term and this is your velocity term. So hope you got it. This is your area into velocity. So like that you can approach the questions if you not remember the formula. So here you can see the graphical interpretation. The graph of your this question, the orifice meter, how look like. Here is the A1 and this is your vena contracta, and here is some eddies formation. This is your vena contracta. So like that the formula is this, and for the venturi meter the formula is this one, A1 A2 minus the similar formula, the orifice meter and your venturi meter, but the thing is A naught in the orifice meter and in the venturi meter is A2. And what is A2? What is A naught? Here is given. A1 and A naught are the area of cross section upstream of orifice and orifice. This is your orifice, not vena contracta. This is your orifice. So the area of orifice A naught and the area upstream. Here is telling the area upstream of the orifice. So here is the area. This is your A1. Now here A1, A2 are the cross section, area of the cross section at inlet, that is the area at inlet, and another one, and the throat. What is throat? I will just show you if the figure is there. So like that. So next question is some numerical question, very important. A pipe is lifting water from pond. Think on that. A pipe is lifting water from pond to overhead reservoir. Means some pond, the water is lifting from pond to the reservoir, some overhead reservoir, situated at 15 meter above the pond. So if this is pond, from here water is lifting up to the 15 meter 50-meter reservoir, let us suppose here reservoir is constructed. This is reservoir. So here water is going like that, and this is your 15-meter above the pond. So the pond level to this is 15-meter. So this is the question. If the head loss through the pump is 5 meter, remember, if the head loss through the pump is 5 meter, here head loss you are losing 5 meter, and flow rate Q is given 170 meter cube per hour, with efficiency also given 60%. Find the power required to drive pump. So how much power you need? So just try to think first what is power. Then based on power, you just try to think the formula for this. So this is very interesting question. I'll tell you. First you just try to solve the question. Very interesting question. So I'll give you the 5 minutes for this, because very important one. Then after I'll explain in very simple way. So within 5 minutes, please everyone just try to write the answer for this question in the chat box. Okay, Ravi is telling the 15.4 kilowatt. Okay, so let us just solve it. So what is actually the power? Work by time. So this is a simple one. So this is power, actually the power rate. And here is efficiency is given already. So for your actual how much power required is power whatever you are getting, and then after efficiency. So the formula for this, rho q gh, always remember, this will give you the unit similar to your w, that is work. So once you will put in this formula, the final formula will be rho qgh divided by, this is percentage efficiency, not in percentage you need to put here. So after your calculation, yes, one thing remember please, here is the very important thing, calculation of head. The calculation of head is very important, because total head you need maintain, you need to lift the water 15, and the 5 meter is loss in your pump. So you need this one and this one also, then you can able to lift the water here. If you will maintain only head this one 15, so pipe is losing this, so you are not able to lift the water in up to the 15 meter level. So remember these things also. So this is very important here. So definitely rho is 1000 because water, and your discharge is 170 meter cube per hour. So you need to convert meter cube per second. So this will be G is 9.81, and definitely your total head required will be 20, and efficiency or 60%. So that's why 0.6 you will get the final answer 15.4. Yes, Ravi is correct. So now we'll move on the next question. The question was, here is bit trick in the question. So total head, always remember you need total head, this H, total head. Now let us move on the next question. Water is flowing through a horizontal pipe of constant diameter, and the flow is laminar. If the pipe diameter is decreased by 50%, we are reducing the pipe diameter, keeping the volume flow rate constant, then the pressure drop in the pipe due to the friction will be decreased by 33%, 50%, 70%, 80%. So again you have 5 minutes for this question. So this is numerical. So just please try to think and try to write your answer in the chat box. So for this question, Nitish is telling option A is correct. Okay. So here question is about the water flowing through a horizontal pipe. The straight horizontal. There is no inclination in the pipe with a constant diameter. Diameter is constant everywhere. Here is D, also here is also D. And flow is laminar. This term is also given. If the pipe diameter is increased by 50%, so you are increasing the diameter of pipe. Initially diameter was D, final diameter. In the second case, the diameter is increasing by 50%, means 1.5 D. Keeping the volume flow rate is constant. So the volume flow rate here is constant. If this was Vc, here also the Vc, volume flow rate, then the pressure drop in the pipe due to friction, then the pressure drop in the pipe due to friction will be decreased by. So here question is talking about the pressure drop. How much pressure drop? Let us suppose here in this case the pressure was something, and in this case, the second case, pressure was P2. So how much pressure drop? The question is this. So here which formula you will apply? So you need to apply the formula which have the relation of pressure and your discharge volume flow rate and your diameter. So like that, something you will apply the relation like that here. So as you know already, the such relation is available, the Hazen-Pauschel law. Such relation is derived by your Hazen-Pauschel law. Hazen-Pauschel, and known as this formula, and this law is Hazen-Pauschel. So what are the assumptions behind it? The fluid follows the Newton's law of viscosity, that is tau is equal to mu du by dy. There is no slip of fluid particle at boundary, that is at boundary level your velocity is 0. So this is the two assumption. Based on the assumption, the formula is del P is equal to 32 mu velocity length divided by d square. So this is constant, this is also constant, mu also constant. Here the variable thing is and q already you know, q is the area into velocity, average velocity. So because you have the volume flow rate in, and volume flow rate is constant here, there is no mathematical value. So how you will deal with this? So first, everything is constant, so what is remaining? Only the remaining is, so let me just first convert this velocity into the volume flow rate, that is discharge. So discharge into area into velocity, so velocity is equal to discharge by area. So discharge pi by 4 into d square, and this will be your q divided by 4d square. So once you will put the formula here, del P, and these are the constant, and V is equal to 4q by this one. So let me just 4q this is pi divided by pi d square, here small d, another d is square is there. So ultimately your delta p is directly proportional to d to the power 4, means this relation. So initially delta p was p1 and delta p2. So this will be equal to, if inversely proportional to, so in the upper, that is the nominator, your d2 will come and denominator your d1 will come. And for d2 1.5 to the power 4, and for this was the only d4. So you will get how much? 5.0625. So this is your P1 divided by P2, delta P2, this value you will get. So question is asking about, so your P2 is how much? If you want to calculate here from here delta P2, so it will be P1 divided by 5.0625. So it is around 0.2 delta P1, delta P2. And now you can pressure drop easily calculated, P1 minus delta P2 divided by delta P1. So definitely 1 minus 0.2 divided by 1 is equal to 0.8. So once you will multiply, you will get 80%. Multiply with 100, you will get 80%. So these are the calculation. This was the very important question, some tricky questions. So once I'll upload these things, so you can go one by one very easily. So again, the small formula from your boundary layer. So for this, just I'll read and I'll show you the answer, because I think these things is not covered yet. So a linear velocity profile, laminar flow is given by this one, u by u infinity is equal to y by delta. If the von Karman momentum equation is this, where theta is momentum thickness and the boundary layer thickness is delta at x, where theta is the momentum thickness, the boundary layer thickness delta at any distance x. What will be the value of boundary layer thickness at x distance? So this is your equal to this 3.64x divided by root Rex. Always remember. The profile is laminar. This is, remember always. For turbulent it will be different. So next question is, a 20 centimeter diameter pipe carrying oil of 20 centimeter diameter of pipe. Pipe diameter is given 20 centimeter. Carrying oil of a specific gravity is given 0.8. A venturi meter is inserted into the pipe to calculate the discharge. So you are calculating here discharge using venturi meter. Remember please. Venturi meter. Throat diameter is given. Dia of throat is given 10 centimeter. Then, and the reading on the differential manometer connected to the inlet and the throat is 10 centimeter. Reading is given 10 centimeter, which connect to the inlet and the throat of mercury. 10 centimeter of mercury. Remember please, 10 centimeter of Hg, and it's having the specific gravity 13.6. Remember these things. If the head loss in the pipe is 30 centimeter, head loss is given also. If the head loss in the pipe is 30 centimeter, then the volume of oil collected in the bucket, if the pipe is operated for 1 minute, will be meter cube. You need to calculate the whatever the volume is collected in meter cube, and pipe is operated for 1 minute. So operation of pipe time is given 1 minute. So for here you need to calculate the discharge. So first for this question you have to know the formula for venturimeter discharge. Then you can understand the things. So please just first you just try within 2-3 minutes or 5 minutes you can take. This is the last question for today, and then after I'll discuss or also the answer. So please everyone just try for this. So please you can just think on that and you can just solve. Such type of question you can expect in your GATE exam, coming GATE exam, as well as your NPTEL exam. Because the fluid dynamic is a important topic of your fluid mechanics. So in any exam from this section you can expect the question. Any exam, whether it is state level exam and whether it is your GATE exam, central level exam, engineering services, and your NPTEL definitely final exam or your semester exam also. So let me just show you the answer. So here is the answer is very clear. So the formula for venturimeter discharge is this one. A1, A2, 2GS, this is velocity term divided by this. For calculating H, you need this. H is equal to X Sm minus S minus 1. This is your, the reading, the value is this. The mercury one, and your this no, this is oil and this is mercury, oil and mercury. So M for, I think, mercury here. Yes. And again, and then your actual discharge, how you will identify your actual discharge? As I was telling you, CD was actual divided by theoretical. So for actual, because you are calculating through formulas, that's why theoretical. For Q actual, what you will do? CD into Q theoretical. And how you will calculate the CD? CD you will calculate like that. Your piezometric head minus head loss divided by piezometric head root over. So these are the calculations. Just you can think. So how you will calculate your piezometric head, whether it is given or not in the question. Okay, so now let us think on that. So diameter is given 20 centimeter and D2 is given your 10. X value is given 10 centimeter, as already I have told you, and the specific gravity of oil is this, and the specific gravity of your mercury is this, and head loss is 30 centimeter already given. So from here you calculate this. X is equal to, so you will get 1.6. Theoretical, once you will put the everything here, you will get the theoretical value. Then after, for calculating the actual, CD value you need to calculate from H minus your loss. Loss is 30 centimeter. 30 centimeter, when you will convert in meter, that is 0.3. That's why written here. You will get 0.9. So efficiency is 90%. You can say already. You can say, because actual and theoretical difference, when you will calculate in terms of efficiency, you will get 90%. So actual, you can calculate 90 into 0.4045. So your actual velocity is 0.4. As you can see, the difference is 0.045, and after calculating the actual, 0.04. So think on that. And the volume collected, if you have the discharge, so discharge is nothing but area into velocity, but you can also, this is meter cube per second, so you can also write volume per second discharge. So for calculating the volume, discharge into time, so you are running for 1 minute, so discharge you are getting 0.04. And why we need here the actual discharge? Because you are collecting the something in bucket. You are collecting something in bucket. So whatever you are collecting in the bucket, that thing only come, the actual thing only come, not the theoretical thing. That's why we are calculating here the actual discharge. Remember these things also, not theoretical. And definitely it is for 60 minutes. So 60 second, 1 minute, so it is 60 second. So after the calculation, the volume will be 2.4 meter cube. So this is about today. So hope everyone got it and understand this question. So we'll meet. Okay. So we'll meet in the next class. So thank you all.
Okay, sir.
Okay, thank you. So please, you can leave the class also.
Okay, sir.
Okay, everyone please, yeah. So hopefully the next class will be your on 19. Okay, please, you can also leave the class. Okay, I think some network issue may you are facing. So